Let's discuss what's new in the new release of HyperLynx AMS. Firstly, HyperLynx AMS can now perform co-simulation with different simulation tools using the Functional Mockup Interface, or FMI standard. Simulation models are containerized in structures named Functional Mockup Units, or FMUs. These FMUs enable co-simulation communication between tools. HyperLynx AMS can now import FMUs generated by other FMI-compatible tools, or export FMUs to be used in other tools. In this example, we wish to co-simulate a control system modeled in SimCenter AIM-Sim with a switched-mode power converter modeled in HyperLynx AMS. To do this, we will import an FMU into the HyperLynx AMS model. To import an FMU generated by a partner tool, navigate to Simulation AMS, Auxiliary Tools, Import FMU. In this dialog, we can locate the FMU we wish to import and define its ports. After an FMU has been successfully imported, it can be placed as a component in the HyperLynx AMS simulation schematic. We can then run the co-simulation with HyperLynx AMS as the master tool and view the results. Alternatively, an FMU can be exported from HyperLynx AMS and used in a different tool. Navigate to Simulation AMS, Auxiliary Tools, Export FMU. In this dialog, we can define our FMU ports, their input-output direction, and the nature of the data on the port, such as voltage, current, etc. After the FMU is successfully exported, the interface block can be placed in the HyperLynx AMS schematic. The FMU is then imported by the partner tool, in this case AIM-Sim, and the FMU interface is placed in the AIM-Sim model. We first run HyperLynx AMS until we receive a message saying that it is ready for co-simulation. Now we can move to the master tool and run the co-simulation. While this is occurring, the two tools are running simultaneously and communicating data through the FMU. Over 250 tools are compatible with the FMI standard, covering a wide range of disciplines, companies, and organizations. The new FMI Co-Simulation compatibility in HyperLynx AMS opens a new world of simulation capabilities and enhanced workflows. The second major feature introduced in the new release is the integration with HyperLynx Design Space Explorer, or DSE. HyperLynx DSE is a powerful optimization tool that allows for large design spaces to be efficiently explored using the advanced Sherpa algorithm to quickly and accurately find optimal design parameters. In this design, we have modeled a DC to DC buck converter with a control system. We wish to optimize the control system characteristics, including the pole zero locations and the gain value. To start, we perform a simulation with nominal parameters. Once we see the results, we can perform measurements of the outcomes we wish to optimize in the waveform analyzer. In this case, the root mean square of the error signal and the maximum error. These measurements are saved so that they can be used later in the DSE setup. To invoke DSE, navigate to Simulation AMS, Analysis Tools, HyperLynx Design Space Explorer. From the integration dialog, we can export to the native DSE environment to set up and conduct the study. This allows us to use the full capabilities of DSE and its environment to set up the study and visualize and post-process detailed results. Alternatively, the integrated DSE wizard in the HyperLynx AMS environment allows for a fast and simplified setup. The first step is to set up the study variables, which define the design parameters that are varied across the design space. We select the desired design parameters and define the range and resolution of parameter values to explore. Once the study variables are set up, we then define the measurements that we wish to optimize. We select these measurements from the ones that were saved earlier in the waveform analyzer. Finally, we set up the study. The study is given a name, and the objectives are defined. We wish to reduce the RMS error and the maximum error so we select Minimize Value as the objective for both measurements. If desired, we could also seek to maximize values, minimize the difference from a target value, or maximize the difference from a target value. We define the number of evaluations to be performed by the study, and finally, we are ready to run the optimization study. After some time, all evaluations in the study are complete and the results are shown. In the best value column, we can see the parameter values corresponding to the optimal design identified by DSE. The corresponding measurements for RMS error and maximum error are shown as well. After setting the design parameters to these best values, we can redo the simulation and observe that both the RMS error and maximum error have been optimized from the nominal simulation. The addition of DSE integration in HyperLynx AMS allows for the intelligent exploration of extremely large design spaces that are impossible to explore comprehensively through manual means. The new release of HyperLynx AMS introduces a new world of co-simulation through the FMI standard and integration with the powerful tool for efficient design optimization.